So my name is Billy Korando, Java developer advocate at a little place you might have heard of called Oracle. And the important information is please at any point ask questions. Luckily, we have the break after this, so we have a little bit of extra time. Though I'll try to make sure to keep on schedule. So if we're kind of falling behind, I may hold questions until the end. If you have anything you want to reach out about, feel free to reach out to me at billy.korando@oracle.com. And the link to this presentation, I just pushed the slides up there again, is at this GitHub link. So are you going to take a picture? Or? Oh, okay. All right, I will continue on then. So, well, I guess now it's only also about just 2 weeks out, but Java 1 is coming back. That's going to be March 18th through 20th in Redwood source. Check it out, register at oracle.com/Java1. You can still get it for like $600, and I think there's plenty of like discounts out there as well to take off $100 of that ticket price. And if you would like to know more, check out dev.java, insight.java, our YouTube channel, and our Inside Java podcast. So actually here coming out with the release of Java 24, I do videos where I go through like all the release notes for every Java version. I've been doing it for the past 2 or 3 or 4 releases right now. It's a good way just to go through all the details, not just the JEPs, but like the smaller changes as well. You know, put it in while you're maybe doing some sort of chores, and that way you can kind of get a full idea of what's all changing with each Java release. We also have an Inside Java podcast. All right, so the agenda, we're going to do a quick review of JDK 11 through 17, and then kind of from there, we'll get into like all the post-17 changes. So before I get started, how many people are at least on JDK 8? Yeah, JDK 11, 17, 21? Okay, yeah, so 17, that's about, yeah, what I'm seeing. Because for a while there, I kind of started noticing that transition from a lot of people moving up to 17 around like last summer. So that's good to see to continue it. I know probably once 25 comes out, I'll have to drop off all the stuff before 17 because it's no longer really relevant. But that said, some of the key changes, just some quick review. Maybe you're missing them. Maybe you're looking for a good reason to still upgrade to 17. Whoops. That's not what I want to do. Yes, so text blocks, those were added in Java 15, and this is with JEP 378. And if you're not familiar with that, JEP stands for JDK Enhancement Proposal. And if you go to openjdk.org/JEPs, that will take you to the index of all the different JEPs. And let's see, that is JEP 378. That's right. So if you were to put 378 at the end here, that will take you to a full write-down on that feature. Obviously, even for this simple text blocks, there's a whole lot of information on here. So there's some feature I talk about that you want to get a lot more detailed information on. Just go to openjdk.org/JEPs and then put that number in at the very end of it here. I guess it's not super great resolution, so yeah, or contrast, but yeah. Just put that in at the end, and that can give you a lot more detailed information. Obviously, I can't go into this level of detail, otherwise we will be here until well into tomorrow. But yeah, what text blocks are, they're simply 2-dimensional strings. So we're all familiar with normal strings. Text blocks allow you to, with starting off with a triple double quote and then a return. You get to do it in a 2-dimensional box, and there's also some reduced needs, so like you don't need to escape out a single double quotes. And then it's basically kind of like what you see here is what you get with the formatting. But it's very nice because if I was to write this out as a normal 1-dimensional string, even this very simple JSON message will quickly become very confusing. It would be also very difficult to maintain. It could be very easy to forget like a simple comma or something like that. Or not have like a new line or something on there. So that is like one of the nice features of text blocks, even though it's a pretty simple change. And that's also something we're consistently kind of see in a lot of the changes that we're adding to Java, that it's about both reducing verbosity, but it's not just reducing it just so you don't have to type as much, but a lot of that change also makes it to where your code is less error prone and also often easier to maintain as well. Obviously, that's two big benefits for all developers. We don't want to have those unintentional bugs and making it easier to read. Then we have switch updates. These were added in Java 14. There was two major changes to it. The first is the new arrow syntax. And with the arrow syntax, when something matches on a case, then only the code to the right of the arrow is executed. There's the old colon syntax is still completely usable. It's not going away or anything like that. But one of the problems with it is that with the colon syntax, it had that fall through by default. So that meant that almost always, you rarely would want to have that fall through by default. So that meant you would have to put within each of the bodies of a switch case that break, and you're just adding a lot of mechanics around that switch to where it becomes, somewhat more difficult to read. And then who here, when refactoring a switch, accidentally removed a break statement and then created a bug in production? I know I did that a couple of times in my career. Very annoying. So now you just even remove that ability to accidentally introduce that bug. And also, again, the code becomes a little bit easier to read as well. So this is being written as a statement, and when it's written as a statement, it doesn't have to be exhaustive. Here, switch can also be written as an expression, and so if it's matching on a case, it will yield or return the value that it's matching on. When you write it as an expression, then it does have to be exhaustive, so that would often mean having to include a default case. Though we'll see how switch has been expanded upon in JDK 21 and beyond, to where that may not always necessarily need to be the case, and also why there's some very nice features around that as well. But yes, so if none of these match, then you would need to have a default case, in this case, to throw an exception. Sealed hierarchies, these were added in 17. If you're just on 17, sealed hierarchies aren't super interesting, but they also become a lot more interesting in JDK 21. But with the sealed hierarchy, at every organization I've been at, there's certain domain concepts that you kind of deal with. So here, I have user, and within users, there's only maybe a certain different number of kinds of users. And in this case, so there's, only an admin, customer, and guest kind of user. So it's a sealed hierarchy. You include the new sealed keyword, and you can optionally then include permits, and then only admin, customer, and guest are allowed to extend off a user. So what a sealed class does is it allows a class to define which classes that it can extend off of it. And this is good for communicating certain domain concepts. Again, for example, there's only 3 different user types, or there can be different transaction types, or certain things like that. That can be a good way of actually running that into code, rather than maybe having to explain that in an outside of code way. But when you define a sealed hierarchy, then those child classes either need to define themselves as non-sealed here, like in this example with the customer, and that effectively makes it like a normal class to where anything can extend off of customer. Or they could be final, which is not new, or they could be also sealed itself in the case of admin, where then there could be either a normal admin or a super admin. So you notice here, I use the permits clause. So when you're referencing a class in a separate source file, you would use the permits clause, and then that would be the, referencing that other class. Or you can do referencing classes within the same source file, like I'm here with normal admin or super admin. But you would either choose to use permits, or you would choose to use it referencing other classes in the same source file. You can't actually mix them. Then records. These were added in Java 16, which up 395. So the first and obvious kind of benefit of records is substantially reducing verbosity when defining simple data classes. But that wasn't the purpose and goal behind records. It wasn't to reduce verbosity. It wasn't trying to do some sort of Lombok aspect within Java itself. But it's part of our goal of being able to support data-oriented programming. In fact, and kind of happy so many people here, but Venkat's actually doing a presentation right now comparing on object-oriented programming or data-oriented programming. And I'll touch a little bit more on it here. But so records allow is a transparent modeling of data as data. So when you define a record here, you immediately have a very good understanding of all this record is. It's going to have these 4 fields of first name, last name, title, and Twitter handle. And the reason that you can then just look at the definition and really have a good understanding is because of the constraints placed upon it. So a record, its superclass would only be record. There's not any other superclass it can be or it can extend off of. So that way it's not going to be bringing in some sort of other additional behavior or some other additional fields. Also, so you can't also then extend a record. All the fields within a record are final, but they're only shallowly immutable. So if one of these if one of these fields was an array or a list or some sort of mutable type, you could change something in there. Like if I had an array, I could add an item to it. Or if I had a list, I could add an item to it, and a record would allow that. So one of the important things with that silo immutability is if you have a potentially mutable class, is what you would want to do is make a defensive copy as you're adding it in, and then also return an unmodifiable example of it as you're sharing it with someone else, just so there's no possibility of something changing under you within that record. You can't also declare any instance field, so only the record or only the fields that you define, or technically components you find within a record at the defining time, are the only fields that can be within it. It will automatically generate hash code toString and equals. However, if, again, kind of use an example of an array or a list or something, if you have one of those as your fields, you would probably want to strongly consider overriding that hash code or equals, because by default the hash code or equals does a comparison based upon reference ID, not the underlying value. So you could have 2 records and have it with 2 different array or 2 different lists within it, and the list could have identical values within it, but because it's a different instance of list, the equals would return false. So you would probably want to override that to actually compare the underlying values of a collection or an array, and not do the comparison by reference. So that's at least something to keep in mind. As I mentioned, you can override those implementations and add your own method definitions as well. It's still fundamentally a normal class. So pattern matching, that's just also becoming a very important story within Java, and it started with pattern matching for instance of, added in Java 16. Instance of, we've all probably used it maybe a couple of times in career, but it's not a super common thing. But if you ever used it, you've had this, or you would have that annoying thing of okay, is this variable an instance of this particular class type? And then within that following if, you would then have to cast it to that same thing that you already checked it for. It was a very annoying pattern you would have to do. So now with pattern matching is you would have a predicate, again, just the standard test of, okay, is this some number type an instance of integer? And if that is true, whoops, there we go. If this predicate here is true, then it would set the result of that to this the pattern variable. And this pattern variable is what's called flow scoped. And what flow scope means is that it's available wherever the compiler or the JVM definitely knows this to be true. And really what you should use it as is kind of as a normal if behavior, where in the following if block, or the following block at the if statement, then it would be available. Technically, you could do some really weird things. If you were to put a not in front of this, then it would be available in the else of it. Or you could do throw an exception and do a not, and then it would be available afterwards. But don't do that, because that would be very confusing to yourself later, and especially to other future developers. But that's just there's not some sort of hard coding within the language to say it's only available within the following block. But yes, so as I mentioned, a big thing with a lot of these changes we're adding is about making Java more compatible to being a data-oriented programming language, or to support those data-oriented programming concepts. And my colleague, Nikolai Parlog, he wrote a great, I think it was an 8-part series that kind of explores of all these concepts, and you can find it at this link. But one of the important things also to take away is you don't have to choose between data-oriented programming and object-oriented programming. You can actually use both of them within the same language or within the same application. You don't have to go through and fully refactor it. But yeah, of course, data-oriented programming is about treating data as data. A lot of the benefits come because when Java was first developed back in 1995 and released, most of the applications we were writing were very large, monolithic applications. That's a lot of the first applications I wrote when I first started programming were large, monolithic applications. So you were working with data all kind of within process, all within your application. But over kind of starting in the early 2010s, things like microservices started becoming more popular. And so we were more often operating at those data boundaries where we're working with a database or working with some sort of external web service to where you're having to do a lot of that data translation. And that's where data-oriented programming starts to become a bit more beneficial is when you're working at those data boundaries. So anyways, check out that series of articles. They can give you some explanation of some of the benefits and the drawbacks of data-oriented programming. Also, there's just a whole lot more of API updates I can't fully get into, but definitely check out our JavaDoc. I guess this link isn't quite ready yet because JDK 24 hasn't been written out or released. Just changed this to 23 for right now, but in about 2 weeks, we'll be on JDK 24. But also, the JavaDoc team has been making a lot of updates to it over these past releases. And so one of the nice things is, let's say you're on JDK 17 right now and you're looking at, and you're maybe making that change to JDK 21. So you can actually go in here and uncheck these and be okay, yep, here are all the API updates between JDK 17 and 21. So you can kind of just get a very selected view of all the updates that you care about. Also, importantly, you also have a similar thing with deprecation as well. Actually, all these features are also available to you as developers. So if you're writing a library for your company or a library for public consumption, you should definitely look at also trying to take advantage of these features as well. It can be very helpful for your users or the other developers within your company. And finally, always check out our release notes. This will give you a link to all the release notes for all the releases. All right, so let's start getting into Java post Java 17, some of these newer language features. I guess any questions on any of the stuff before 17? Okay. All right, so the next thing for pattern matching was pattern matching added for switch. This was added in Java 21 with JEP 441. So one thing to keep in mind is that whenever you're using pattern matching within switch, even if it's written as a statement, so you're not returning the value of it, but you're just matching on it, it does have to be exhaustive. But also one other really nice thing is now you can also handle the null case within the switch directly. So here we have, just working with a simple switch here. And we also have a guard condition. So we have okay, if it matches on the type of triangle, then I can actually investigate that field within triangle, say, for example, checking the area of the triangle. And if it's greater than 100, then I can do something different with it versus if there's a normal triangle or a triangle that's a smaller size below 100, then I'll do something separate from it. Obviously, the cases below, these can't dominate below cases. So if I tried to flip these two around, if I tried to put triangle T first, then I would get a compiler error because obviously it would be unreachable code to try to get to this case then, the one that I have highlighted. But yeah, even though this is being written as a statement in this example, it still needed to be default, or in this case it needs a default case, or it needs to be exhaustive because again, I'm using pattern matching as I mentioned. Let's see, but yeah, then also I can handle null directly within the switch as well. So this can be really nice if for some reason what you're switching on has a possibility of being null. You no longer have to wrap that switch with a null check beforehand, you can actually just put it directly within that switch as well. Again, making things a little bit easier to read and understand. But yeah, I talked about sealed hierarchies a little bit earlier, and so this is where now sealed hierarchies start to become a bit more useful. So in this case now, I rewrote these shapes to be as a sealed interface. So now triangle, circle, and square, these are the only things that can implement the sealed interface. And because then in this following sealed hierarchy of the switch, I'm covering triangle, circle, and square, so all the different possibilities of classes that can be implementing shape. And because I covered it, it's now exhaustive, so I no longer need a default case. And so what this is very useful for is potentially avoiding introducing bugs. So it can be very easy, or it can be a case where it's like, oh, okay, we're going to do something crazy. We're going to start, working with pentagons, and maybe even hexagons into the future. So if you were to add that, now you don't need to necessarily just depend upon automated testing to catch that you're, covering these in other areas. You would get a full-on compiler error and can't even ship this code to production because you're no longer catching. It'll throw an exception saying like, hey, this switch is no longer exhaustive. So that's a good way, again, of how things become a little bit easier to read. You're also becoming a bit more safe, that you're preventing introducing bugs within your code. So a very nice change there, and a reason to start taking advantage of using sealed hierarchies. So record patterns. So record patterns, it's basically like using a deconstructor on your record. So, we have obviously a constructor where you knew an instance of a record and you add your fields into it. Now a deconstructor almost looks like that in reverse, where you're then taking all the fields out of it. And the way it works, it only needs to match on an applicable type. So here you see how I have like record defined with like first name, middle name, last name is all strings. Here I'm using the variable or the local type inference. And so using var, so it can just automatically match this be a compatible type of string. But you see like I'm using different names here. I'm using F name and M name and L name here. You would probably want to actually use the consistent naming of it, but this is just to demonstrate that you don't have to match on that naming of it. You can also use your record patterns within a switch. So again, here I'm using it to pull all the values out of it. I'm also using it with like a guard condition that, okay, if middle name isn't empty, then I will print it out a different way using like the last name followed by first name and then middle name. If a person doesn't have a middle name, then I will print it out a slightly different way. So yeah, you can combine them together. So one issue potentially with this though is if you did have like a pretty complex record type with 10 different fields in it or something like that, this could start to look a little bit messy. So one of the things we added then was the unnamed patterns and variables. And so here we have like, okay, I'm combining together a few different record types, like a name, address, billing, and customer. So that'd be kind of pretty typical for like what a lot of organizations would need for tracking, users or customers or whatever it might be. And so like, let's say for example here, all I really care about is maybe validating a person's billing address or just extracting that billing address to do whatever I want to it, for shipping something to a customer. Well, right now, before the unnamed patterns, I would still have to reference all of these other fields, and then it can get a bit messy, and it can also be a little bit confusing for future developers to know, like, wait, are we supposed to be doing something with these other fields? We defined all of them, but we're never ever actually referencing them. So with unnamed patterns and variables is, if I'm not going to use it, then I can just put a underscore there to say like, okay, I don't care about this. I only care about billing address. And then that way it's just much more clear to a future developer that, hey, we only care about billing address here. It's also a little bit, easier to read. less typing as well. So important thing though is that like the JVM generates some like random like identifier for this. So by doing this, there's no performance advantage or anything like that. If you were to look at this in a debugger, like, you know, there would be just like some randomly generated ID for these fields that you have as unnamed fields. So don't think you're getting some sort of performance benefit from it. It's purely for readability. But yeah, you know, you can also kind of really fully collapse things down as well in some cases. Like let's say I was only caring about name, then I don't have to explode out like the address and billing and all that stuff as well. Again, that could greatly improve the readability of your code. It can also apply with like variables. This is just an example I pull out of the JEP. But like, let's say I have like a for loop I'm going through, but I never actually reference the n variable, then I could just replace that with the underscore. Something a little bit more practical could be like if you're maybe doing some sort of client validation on a field, and somehow for some reason, like, you know, age can be a string, and somehow like an invalid value like cat is passed in, then you know, it catches it as an illegal argument exception, but you know, maybe in a case like that, you wouldn't necessarily want to log that exception because it's a client error and it's not really something that you need to be logging, perhaps. I mean, you might want to log it anyways, but in this case, you can just be like, oh, you know what, we're not going to really do anything with that exception. We're just going to send an error back to client about that, or I guess maybe do a simple logging saying that because, like, you know, we don't really need to go through the stack trace and maybe in that example. So a new feature now that we're really getting here now up into JDK 24 is stream gatherers. So we've all used maybe streams a few times or maybe quite often, depending on if you're a really big fan of more functional programming. I'm still in imperative days, so I'm not always so often using streams. But yeah, so here in this simple example, like I have a bunch of speakers from here at Devnexus, and you know, we can do a few things with it easily. Like here, I'm just saying like, okay, whoever has like a name with 5 characters long, I know this is a very arbitrary example, and that would be like 10 if we were to print that out. But what if we wanted to do something different? Like, you know, we wanted to make some modifications and groupings or something like that within the stream. Our options are pretty limited. So like, you know, it'd be really nice to say like, okay, I have a window of these different items that could be grouped together. Like we can't really, like you couldn't do this pre-gatherers. Like this is like some of the hypothetical stuff we would like to do that's not really possible before. Or here, maybe it's like you want to maybe do like a distinct by options within that, like give like an arbitrary thing, like the length of it, you know, or it could be like by the first letter of someone's name or whatever it might be. And it could be some options, but you couldn't really do that before gatherers. It would be already be very difficult to actually write that out and be very confusing to look at. So what gatherers are, so like we have a collect where you can just kind of at the terminal operation within the stream kind of, you know, have a lot of transformation ability to kind of work with something, but then if we wanted to do further transformation on it, then we would have to start a new stream. Gatherers are basically an intermediate version of collect. And so here in this example, you know, using the new gather operation, I'm now using like a fixed window to, you know, group together just various items within my stream. In this case, I'm just like, you know, every 4 items, put it together, and then I'm only doing 3 of them and returning that value. So the gatherers are some pre-configured options for gatherers. There's, I think is it 4 or is it 5 of them? Yeah, sorry, 5. So there's fold, map concurrent, scan, windows fix, and sliding. So those are already pre-built gatherer options, but fundamentally what the purpose of gatherers or a goal of gatherers is to be an extension to kind of fit all the different kinds of options. Again, for example, like distinct by, if you wanted some way of like, you know, just different from just a normal distinct, but like distinct on a specific characteristic within the objects within a stream, You can implement that behavior yourself. And so what you would do is you would implement the gatherer interface, and you would need to at least implement both the initializer field or the initializer method. And so this would be then the carrier of whatever you're transforming it. You want to then store that to it. So that's what the initializer would be used for. And then the integrator would be kind of whatever transformations you would want to do to it as well. Then there's two other ones. There is the combiner. And so this can also accept two interminable states and combine them to one, and then a finisher. So once you get to the end of a stream, if you wanted something else like an exception to be thrown, or maybe like a period at the end or something different to happen to it, you could also implement a finisher behavior. But back to here. So here in this case, I'm creating like a distinct by gatherer, and then I am referencing it up here. However, there's also the static constructor or the static builder where you can do gatherer of or gatherer of sequential, to where if you have a relatively simple custom behavior you want to implement, then you can kind of do it with these builder methods that are available within gatherer. So gatherer of and then gatherer of simple. There's each like 3 or 4 overload methods that you can also implement some sort of more simple custom behavior without actually necessarily having to write out a full class if for some reason that worked better for what your needs are. Back in JDK 21, sequence collections were added. And it moved up some methods that were implemented in some lower level classes. So for example, like queue and stuff like that in DQ, they had certain things like add first and add last, get first, get last, remove first, remove last, and an ability to reverse a sequence. These are simply kind of moved up higher within the collections hierarchy to make them more broadly available. And then that was also the case with map as well. But yeah, I like to show this hierarchy. So a lot of times when people are using a list within our list, it's often going to be the array list option, in which case you would get like the benefit of all the sequence collection when you're using that, which is very nice. However, a lot of times when people are using a map, they're often using a hash map, and hash map extends off of map. So if you would want to use the sequence map new API, you would need to either use a sorted map or a navigable map or a linked hash map, something that extends off of that. So that's just something to keep in mind. Like, oh, hey, I'm using my hash map. Well, that's not ordered because it's using a hashing function, obviously. So you would just need to use a different map implementation to take advantage of those new API. So the big change that came in JDK 21 was virtual threads. So this is like the first delivery out of Project Loom, and what it did is it created it separated out the thread model where you created a lightweight existing in pure memory thread, and it greatly improves like the potential to concurrency of your application. Eventually, the goal, we're going to be adding structured concurrency. So right in JDK 24, there wasn't any changes to it. However, there's hopefully going to be a whole new API, a big API rewrite that's going to be coming in JDK 25. Scope values should hopefully become finalized here in JDK 25. But yes, so all your code within Java runs on thread. So from simple hello world to your very complex monolithic applications or enterprise-grade applications that you're all working on, they all run on threads. Now, and so threads are fairly heavyweight. And so within your application, there's a pretty, dozens to hundreds of threads typically you can run on a machine before you start to kind of no longer get a benefit, or you would have to wait before another thread would stop before you could get another thread to execute. So here, this kind of represents your overall JVM and your various threads running within it. Now, if all of those threads are fully occupied, like you're doing like some sort of batch application all in process or all in memory and stuff, then that's fine. If you're fully utilizing CPU, there's no reason to need another thread because you're not going to get any more out of it because you're fully utilizing your CPU. But how many people here are web developers or work in a web application? So a lot of you. So on a web application, though, most of the time your threads are going to be sleeping because like you get a request in from your client or whatever, and then usually you're going to then make a call to the database. It's like, oh, okay, this person's customer ID, whatever. Check the database to load that information up. Okay, they are updating their order. Okay, we're going to send that off to like some other remote service and to update the order or update inventory, and then it's going to come back. So during that time, during that call to a database or call to some other external service, that thread is just sleeping and it's not doing anything. So we expand this out to what your application kind of looks like on the JVM is you could have, be near full utilization on your threads, but a lot of times those threads could be sleeping because, they're calling out to something. So you could be having like a very high memory utilization, high thread utilization, but your CPU utilization could be very low. And that's just not an ideal use of your system resources. You might have to be spinning up additional instances or something like that to still meet customer demands, but you're not fully utilizing all the resources you could. So virtual threads, they split the concept of thread into two parts. There's a platform thread, which is functionally equivalent to existing threads. And then there's a virtual thread, which runs on top of a platform thread, and they exist purely in memory. And then they're managed by the JDK, and they're managed in a fork join pool that's a first in, first out. So here, like a bunch of requests come in, I have available threads, and so then the JVM will, put those virtual threads on the available platform threads. And if then they run into some sort of blocking operation, then the JVM can then unmount that virtual thread from that platform thread and then put it back into the queue and then take some other virtual thread that's on the queue and then put it onto that platform thread. And so what you end up with is a much better utilization of your resources. But then what's nice is to you as a developer is that the context, the stack, and all that sticks with that virtual thread. So even though this virtual thread started on this platform thread 1, and then goes down to platform thread 3 here, as far as when you're looking at the stack trace, and the variables and all that stuff, that's sticking with the virtual thread. So you don't have to redesign your application to take advantage of virtual threads. It's kind of solving for a lot of the same issue that like reactive programming is solving for without having completely rewrite your application to be reactive, which I can never get my head around. Like it was always very confusing to look at, also very confusing to debug because you can have an exception happen and it can be very difficult to trace back. Like, okay, wait, what caused this exception to happen? You lose a lot of that context. So you get a lot of the benefits of reactive programming, but can still continue that imperative programming where it's very easy to read, very easy to debug. Any questions about virtual threads? I know that's a lot of information. Yes?
My first question would be thread local, which are you saying that follows the virtual thread, or that follows, it stays on the...
Yeah, thread local would stick with the virtual thread. So yeah, obviously if you're making heavy use of thread local and then you're using a lot of virtual threads, so another advantage that comes with like virtual threads, when you spin up like a new thread, like I think it's about like just the construct of the thread itself is about like a megabyte or so, and it takes like a few milliseconds to spin up. Whereas a virtual thread is like only 4 kilobytes on the Java heap, though of course whatever variables, thread local and stuff you add to it, that will expand the size of it. So if you're making a lot of heavy use of thread local, then that would be something that could start to expand if you're using then like thousands or millions of virtual threads that can start to use up a lot of memory. Though that's also where scope values would come in, and I'll touch on them in just a moment. Any other questions about virtual threads? Or?
So these virtual threads and Kotlin coroutines are?
Yeah, they're pretty similar. I haven't done a whole lot of Kotlin code routines, so I can't get into like the real underlying specifics, but they kind of are in that same vein of that behavior, yes.
How expensive to put it on sleep and then return to execution? How much time?
You know, I don't know offhand. I mean, there is some amount of it. So where, you know, if you are very keeping everything in process to where you're not actually doing a bunch of, if you're not doing like I/O work or doing stuff, then you would maybe want to avoid using virtual threads. But again, it's usually pretty minimal, and in a lot of cases, the benefit of virtual threads is worth it. But yeah, then there's the foreign function and memory API. This was added in JDK 22, JEP 454. So this is an improvement upon the Java native interface. Now, my background is a web application developer, so I've done virtually no work with the Java native interface before. So if you're interested in that stuff, this is a very nice improvement. Like, it's a much more consistent behavior. It also avoids some of the potential traps when it comes to working with native memory that was there with the Java native interface. But like I said, my background isn't really in this area, so it's like, oh, that sounds awesome. But I can't really say from experience the improvement of it. But one of the things we also provide is the JExtract tool. So this can read the native library's headers and then kind of mechanically construct the bindings to then work with that native library in your Java code to then, yeah. So if you're wanting to use some sort of native library for like, you know, AI work or something, then this JExtract tool can read that, and then you can more easily work with it. And that's available at the OpenJDK /JExtract. Markdown was added in JavaDoc and JDK 23. And so Markdown or JavaDoc, like the markup within it is HTML, but obviously HTML can be very garish to look at. and Markdown is in most cases, much simpler. So if you want to do some sort of formatting, you just start it off with a / for a line, and then it will be Markdown for that line, and it uses the upmark version of Markdown for its syntax. And then finally, this is also going to be finalized in the JDK 24, is the class file API. Many people here will never really work with it, but it's going to be very useful for when it comes to upgrading. So a lot of like things like Spring and a lot of like ByteBuddy and ASM, they generate code, but like whenever a new version of Java is released, then like that generated code is no longer compatible because like it has like a different class file version or whatever. That's a way to make sure like it's for validating with the JVM. The class file API is not going to allow the JVM to actually inspect what's within that class file to say like, oh, okay, no, actually none of like the actual stuff I care about has changed, you know, between these two releases. So this way it's to make it to where you're not necessarily going to have to always update all your dependencies whenever you go to a new version of Java, if, you know, assuming there's no other updates for it to be needed. So starting with JDK 24, actually upgrading between releases should get even a little bit easier, which will be nice. There's been a bunch of runtime features and tools have been added. How many people have heard of CDS? 1, 2, yeah. Okay, I'm glad. Usually it's about 1 or 2. This is a very overlooked feature, but what it does is whenever you start up your JVM, like it loads a bunch of class information, and like that's always going to be the same because like it's always having to load these class files. CDS allows you to this information to be read and then stored into an archive and then loaded on subsequent startups, improving startup time, which can be very nice. Over the releases, they've made it very easy to where if you're on JDK 19 or later, all you need to do is include this auto-create shared archive. And if that archive then, in this case, foo.jsa is available, it will load it. If it's not available, then it'll create it and then place it in the location where you declare it, and then load it on subsequent startups. And what's nice here is because before, the creating the archive and the using of it would be different commands. Now within like your build pipeline, it can be the same command. That way you're not having to maintain two different commands. A very nice thing, a nice feature that's overlooked. And what's also nice is, like, let's say this foo.jsa is like corrupted or something wrong with it, then the fallback for the JVM is just to be like, okay, this shared archive isn't working. It'll just like load the classes up off the file system as normal. So like the fallback isn't like your application doesn't start, it just starts up a little bit more slowly. So it's a nice fallback, so it's very safe to use. But now it's being expanded upon. So Project Loom, it's a new project, or a newer JDK project that is seeking to improve startup time, time to peak performance, and then reducing memory footprint. So the time to peak performance is within the JVM is the just-in-time compiler. So as your application is running, this just-in-time compiler will be like, it'll be profiling your application, like, oh, okay, like this if statement's like always true, or you're calling this method a whole lot, and like it will recompile the code. So like the goal eventually of Project Loom is to kind of store this information in a cache to load up. Like you do a training run and you can store that information. The start of it though is with ahead of time class loading and linking with JEP 483. And so right now it's kind of annoying. It's like a 3-step process where you first do a training run, and then you create the archive, and then you load from it. But the goal would be to improve the ergonomics around it to where it could be like a 1 or 2 command thing, but you run some sort of training run within your pipeline. It will then record that information and put it into an archive, and then on subsequent startups, it will improve the startup performance. I can't quite remember offhand, but like they had pretty good improvements when doing some test cases when using like things like the Spring Boot Pet Clinic sample application, where they got like a 20 to 40% reduction in startup performance. The simple web server. So if you just need like a little web server to start up for like testing purposes, this is also very useful for students. We now include a simple implementation within the JDK. I'm actually running this application or this presentation off of it. So like localhost, that's actually starting from that here. It's not meant for production. There's no security around it, so do not use this out in production. That will be a very bad day for your organization. Generational ZDC. So back in JDK 15, I believe that is when ZDC became a production feature. At the time, it was single generation. Then in JDK 21, they made it generational. And the longest sort of that is that this improves memory utilization and also reduces CPU utilization just a little bit as well. So they added that as an option, and now with JDK 24, they're removing the old single generational option to where now if you're using ZDC, it's always going to be generational. Starting with JDK 23, it was a default option. So but yeah, definitely check it out. It's a ultra low latency garbage collector, so it's like sub-millisecond, and really in most cases it's like 200 to 300 microseconds or even shorter for latency. So that could be very useful for web applications. Though the trade-off is there is higher CPU utilization with it, so that's that could be a bit of a trade-off. If you're really concerned about CPU utilization, then you might stick with the G1 garbage collector, which would be the default one. But if you're more concerned about latency, definitely consider using generational ZDC. Test it out with your applications. That said, the G1 garbage collector is still receiving regular updates. The region pinning is very important for if you're doing native memory work. In JDK 24 here, they added a new JEP where basically what it's doing is reducing the CPU utilization for the C2 compiler if you're really interested, definitely check out those steps. They're both very technical. Also, the ability to launch a multi-file source code application. So this is part of our educational outreach. So if you're kind of early on starting with like writing some applications, now you don't necessarily need to jump up to using things like Maven or Gradle to kind of build maybe a simple 2 or 3 source file application. Now the Java launcher can actually be like, okay, your main method here, your main class is here, and it's referencing these other classes. As long as it's following like a proper package structure, the Java launcher can automatically compile and load those applications. Again, very useful for if you're just starting to learn, but also can be useful if you're writing some simple like script or utility applications as well, that instead of having to like Java see it, jar it, and then launch it, you can just run the Java command, and it can do all that automatically for you. There are a few deprecations, changes, and other removals. If you're still on 32-bit Windows or Linux or anything, that all the 32-bit ports are either being removed with JDK 24 or in the process of being removed for Linux. So it's time to get off those. Also, there is continued restrictions being put on SunMISC Unsafe. I'm guessing no one here is directly using it, but your underlying libraries might be doing that. So now, if you do have a library that's doing that, if it's referencing some of the memory access within SunMISC Unsafe, it will print a warning message out. So for the library developers, hopefully they're moving off of it, but definitely maybe check your logs just to make sure none of the libraries are using it. And if they are, consider making sure to upgrade those libraries. Also, the permanently disabling of the security manager. So the security manager, the real purpose behind it was back when applets were a thing, because you would be potentially bringing in, like on your JVM, some new third-party code to run on it, and you would want to make it set up with the security manager saying like, okay, only these packages or only these classes would have like access to the underlying file system. But because applets aren't obviously really used anymore, they're actually outright disabled starting with JDK 17, that kind of reduced the need for the security manager, because all that can be more easily done at the actual like operating system or container level. So that's why this is being disabled, and it's just creating a bunch of overhead when it comes to maintaining Java. So it's permanently disabled. The APIs are still available, but the goal is to eventually remove the security manager altogether in a future release. So getting into the beyond, I mentioned structured concurrency. So it's going to make rewriting of concurrent code much easier, because like right now, writing concurrent code in Java isn't so great, particularly when it comes to like let's say if you have like 5 tasks being executed concurrently and like one of them fails, there's no way to say like, okay, we'll cancel the other ones. There's no easy way to do that. Like structured concurrency provides that way, or if one of them fails, like how to kind of handle that information. It's going to greatly improve writing of concurrent code. The API, this is the older API, it's going to be getting updated here in JDK 25 to be much better. If you kind of follow my GitHub, I have like a bunch of examples of using the newer API within my GitHub repository under Illuminated Java. So check that out if you're interested. I'm really looking forward to it when it's going to be available. Also, there's scope values. So you were mentioning like thread locals earlier. So scope values are kind of like a update over thread local that are kind of working within the context of virtual threads, and particularly working well within the context of structured concurrency. But like thread local, obviously it's like you're storing a value local to every thread, but like maybe if that value is like a customer ID or some sort of common value across all this concurrent block, you can store it in a scope value, and then that way that value is not being copied across all the threads, and it can be referenced for later in a very fast manner as well. So definitely something worth checking out as well. Also check our YouTube video. We actually, one of my colleagues, Nikolai Parlog, recently released a video kind of covering the differences between thread local and scope value, where you would use one versus the other. So definitely interesting. The Vector API, it's in its 9th incubator, and that's where we remain pending Valhalla features when they start delivering. Flexible constructor bodies. This is in 3rd preview of JDK 24, and I think it's planning on being a finalized feature in JDK 25. But simply what this is allowing is you can put statements before a call to super or this with a constructor, and that can be very nice for setting either like a default value or doing some sort of validation on values before making a call to super, because then you can save some unnecessary work. So like in this example, it's extending integer to be positive big integer, so obviously implying that only positive values are stored within this class. And like so right now, with final features, like you would have to make a call to super and then do potentially unnecessary work before checking to make sure a value is either over or non-negative, or you would create like some sort of static checker method and then put that within like the call to super. But now you can just have a very straightforward, doing calls before a call to super to check to make sure validation before actually constructing the object. Primitive type patterns, just as the name sounds, for things like within a switch, instead of like having to wrap it as like an integer type or a long type, reference type, you can just handle it as a primitive type. It's just about making things a bit more consistent, not unnecessarily having, again, to wrap this up in like integer value dot of 1 or 2 to actually reference it with pattern matching for switch. Then there's also implicitly declare classes and instance main methods. So again, this is going back to our approach for improving outreach to students. So when students first are learning how to write Java, your first application is always going to be your hello world. But we're introducing a whole lot of concepts here. We're introducing access with like public. You're doing things like class, static versus instance, method, method arguments, and so on. Like you're introducing a whole lot of concepts. Now, teachers are very smart and very capable, and a lot of times I don't just tell them students like, hey, don't worry about too much of this dressing right now. We'll just kind of focus on the stuff that you're actually changing here, like system out print line, and then they'll get maybe to like adding like a method or adding like variables and if statements and all that stuff. But it could be nice if we were able to kind of really pare some of this stuff down to where you're focusing on only what you're trying to teach at the time and then add new elements on later. So eventually, actually, this is actually we're going to be probably change it to where it would be like io.println, but that would be much more consistent, and then you can kind of build it up from there for students. Now, this isn't just for students. This could, again, I was touching on it earlier. This can also improve it for using Java for writing scripting or small utility programs as well. I know back in college, like I was using Bash and a bunch of stuff like that, but I've like forgotten all of it since then. It's kind of nice. I can just go to like Java to like parse out like a CSV file or something like that instead of trying to remember how to do that in Bash. That's one nice little benefit that you can just kind of write out that simply with Java and stuff like that. Also module declarations. Sorry, I forgot to add the code examples here, but basically is instead of like, you can just do like module imports and then the name of the module, and then it will import all of the published APIs from that in a single line. So that can be a way of just not having to do a bunch of different class imports. You can just do it all in a single line. So that's very nice and beneficial. But yeah, if you want to learn more, I referenced it several times, what's called paving the on-ramp. You can read this white paper by Brian Getz. He's the chief language architect for Java, and he kind of lays out the vision behind it as well. So a very good and worthwhile read. But yeah, some follow-up links. So back when we released JDK 21, myself and other members on our team, we produced a bunch of videos like how to upgrade from 17 to 21, like all the new language features, all the new runtime features, and so on. So you can check out that playlist at that link. When JDK 25 comes out later this year, we're going to probably do that again as well to kind of cover all the big language changes, all the big runtime updates as well. So that can be a good way to kind of cover all the major changes. Actually, I guess I need to update this link to be JDK 24 when it's released, but you can check out the release notes there as well. Also, as I mentioned on our YouTube channel, I'll be releasing videos going through all those release notes if you don't necessarily want to read them, because trust me, it's very dry reading. So if you wanted to listen to it instead, you can do that. That said, thank you, everyone. And yeah, any questions then, or? Oh, thank you. And I guess I forgot to mention, so my previous speaker, Chandra, offered to give chocolates out, and he said, I can use them as well. So if you ask a question, you get a chocolate. Any questions then? Yes? Huh? Yeah, exactly. All right, you get one anyways. All right, so. But any other actual questions, or? Okay, well, if anyone has, oh, yes?
Question about thread local.
No, there's no, thread local is still available and not going anywhere. It's just that we also are now adding the new scope value API that should be finalized in JDK 25 that can make sure be more memory efficient when using virtual threads. So, yeah.
It will improve the memory management.
Yeah, because it will only be a single instance of that scope value that can be shared across many virtual threads. Yeah. Great. Yeah.
So it's a long-winded question, but as I understand, if you just migrate, say, Java 17 to 21, and your platform threads become virtual threads, or like say incoming web requests.
Yeah.
And you're doing synchronization inside. It is potential. There's a case where you can actually pin them.
Yes. Yeah. Sorry. That has been. I thought I included it in the slide, but there is a JEP in JDK 24 that resolves that issue, because yeah, that was raised by like Netflix in a blog article.
So if you're going to 21, which is what we're doing because it's an LTS.
Yeah.
That is a concern, right? You could potentially break your application if you just go to 21.
Yeah, I'm trying to think.
Huh? No. If you're just doing Spring Boot 32, all your incoming web requests will automatically become virtual threads.
Yeah, I think it could depend. I think you can disable it, virtual threads, to where it would, because like, so it's like some of the underlying technologies would also have to like sometimes take advantage of the virtual thread as well. I'm trying to think maybe what fallbacks there are for that in JDK 20. I can't quite remember offhand. Yeah. Okay.
Which version do you use?
21. Well, actually 23, but whatever.
Yeah.
No, which version of Spring Boot do you use?
3.4.
Okay, and so your incoming web requests are not, by definition.
Yeah.
Oh, okay. That's good to know.
Yeah. There, thank you. Yeah.
Okay.
Okay.
All right, and so basically, you really just need to go through your application and see anywhere where you have synchronized.
Yeah, you would want to avoid that. And I think there's actually, with JDK Flight Recorder, there's actually ways of enabling to see where you might be using a synchronized block within your code. And then you're probably not using it like within your own code, but rather an underlying library. And then hopefully that library has an updated version that removes that synchronized block. But yeah. Yep, absolutely. Did you have a question?
I have a doubt about records. When do you use Lombok? You already have records, right?
Yeah.
Do you still use Lombok? Is there any situation?
So, I mean, Lombok and records are trying to solve somewhat different issues. Like Lombok is purely about reducing like the boilerplate code. And then also like Lombok, like it doesn't give you some of the same guarantees, like, you know, like the fields, I think a lot of times are still going to be mutable or something like that. And like it's doing like a bunch of tricks as well to like do all of its work. So, I mean, if you love Lombok, I guess continue to use it still. But you know, but yeah, like I said, records and like they're trying to do a specific thing of transparently modeling a data as data, whereas again, like Lombok is more about just reducing boilerplate code within your application.
Keeping all the variables inside the record.
We would
Yeah.
suggest it, but for
Feels
sure
like,
this will help.
not
It
really.
will help increase the confidence.
Yeah. I mean, I think it is being inspired off of data classes in Kotlin. Yes. Mm-hmm. So yeah, absolutely. Yeah, thank you for a great question. Yep.
Yeah, thanks for the nice session. And like, just want to confirm one thing: the instance of when you mentioned that instance of something.
Yeah, I would say.
So you assign to a variable that then we can go forward and use that variable instead of like again doing the same.
Yeah.
Kind of thing.
Uh-huh.
Like that's shortcutting that again doing the same thing once you know that this is.
Yes. Yeah. So yeah, once you don't have to like recast it or something, or you don't have to cast, be like, okay, like, yeah, it's an integer, and then cast it as an integer in the following if block. It just automatically assigns it to that pattern variable for reference later.
Okay, so it's doing two things at the same time.
Yes. Mm-hmm. Absolutely, yeah.